That's okay.
I think she's dead.
Well, we got batteries.
Well, I think she might be like dead.
Nope, not only do we have batteries, but she turns on. So
What? Oh my gosh.
the world we live in.
It's a miracle.
This is yours because it says your name on it.
I know. This is mine from high school.
Hi, everybody.
That was weird. You can leave now. Look at all the people that are on.
I'm going to take my books. They're so heavy. Well, yeah, it was weird that I said that to nobody.
0 people watching.
How's Harper doing out here? Nope.
Sniffing?
Nope, she's digging. I'm gonna
She's digging. Oh, good. Go get her. Okay, bye.
Bye.
All right. Well, all 0 of us are going to get started since we're a couple minutes in. If you're watching this on a rewatch, hi. And we are going to review Unit 8 and 9. If at any questions, if you're watching this live, you guys can send them on Remind or via the YouTube chat. If you have any questions while you are watching this later, you can send them to me then. So don't be shy. This is our last live stream review for a test, and we are almost done for the year. So we're going to start with probability. And probability tends to be the thing, honestly, that I would say we probably are going to struggle a little bit more on. So this right here, these are all the formulas I would say that you should know for your test on probability. You will not be given any of these. And really, there's 2 big ones that I would say you absolutely need to know. So here's the first one. The probability of A or B is probability of A plus the probability of B minus the probability of A and B. So what this is saying is probability of A union B, which is OR, so that's this whole thing. That's A or B, is the probability of A, that whole circle, plus the probability of B, that whole circle. But notice how in here this got doubly as dark, right? And that's because that's my overlap. And so this is subtracting out the overlap. So that's a really important formula for you to know. A or B is A plus B minus A and B. So subtract out your overlap. From there, the other one that you really should know is your test for independence. So if 2 events are independent, the probability of A and B is equal to the probability of A times the probability of B. Again, that's only true if they're independent. And if that's true, that means they're independent. Okay? So ways to show things are independent, either by showing that that is true or by showing that the probability of A is equal to the probability of A given B, or vice versa there. And mutually exclusive things mean one can't happen if the other happens. So it's either raining or not raining. The overlap of those would be 0. It can't do both. So those formulas, good to keep in mind. If you look on the back of your stamp sheet, they are on there. So feel free to look there if you need a list of what formulas would be good to know. So let's actually get into doing some problems here. So, starting with this one, the following table describes the departure of buses out of a bus station for the past summer. What is the probability that the buses are each of these things? So, let's start with being on time. So, on time would be anything in this column. So, the probability that we're on time here, well, there's 112 on time out of 200 total. So, that would be my probability of departing on time. Now, probability that it's delayed given that it left in July. So this is the probability that I'm delayed, given that I know it's the ones that left in July. And so what you need to remember here is that your subgroup are only the ones that left in July. So your denominator here should be 79 because we know that that has to be true, right? Whoops. Now, what of those got delayed? So which of those 79 got delayed? That would be 35 of those. And you don't need to reduce these, right? You can leave them the way they are, so that'd be 35 over 79. Now, what's the probability that they are being delayed and the month of June, or are these independent events? So let's say being delayed is probability of our first event, and being in the month of June is probability of our second event. So here's what we want to check. Does the probability of being delayed times the probability of it departing in June equal the probability of it being delayed and departing in June, right? That's our test for independence formula. So probability of it being delayed is 88 out of 200. Probability of it departing in June is 30, nope, sorry. is 63 out of 200. And probability of being delayed and departing in June is 23 out of 200. Now, often the best way to tell if these are equal is to actually just multiply them. So on the left side, on the right side, 23 out of 200, this would be 0.115. And on the left side, I have 88 over 200 times 63 over 200, and that's going to give me 0.1386. So I'm noticing here that these are not equal, right? And so because of that, I would say, are these independent? No. So if they're not independent, you could say that means they're dependent in some way, but we at least know that they're not independent, right? So independent should make you think test for independence. All right, next one. The math department has to report out to the Board of Education about student enrollment in higher level math courses. The report indicated that 18.4% of the senior class were enrolled in AP Calc, 12.4% were enrolled in AP Stats, and 3.6% were enrolled in both. Find the probability to the nearest hundredth that a student is enrolled in AP Calc given that they're enrolled in AP Stats. So here's what I'm really thinking about. Probability that they're in calculus given that they're in statistics. So remember what we're really looking at as the group that are in statistics, right? There, we want the people who are enrolled in statistics and calculus. So really what I'm looking at here is people that are enrolled in statistics, which is 12.4%. And then people who are enrolled in statistics and calculus, which is 3.6%. So that's what I'm looking at there. Now, if this doesn't make sense to you, which again, I can calculate this. So 0.036 over 0.124 would be, to the nearest hundredth, 0.29. So about 29% probability there. Now, if that was tricky for you, remember you could always draw a picture. So you could say, okay, these are in statistics, these are in calculus. I know that 3.6 is in the overlap. And in statistics, I know that there's a total of 12.4%. So I'm going to do 12.4 minus 3.6 to get what's in that remaining portion, which is 8.8, right? And you could do the same thing to get this over here. But really what we're looking at is this part out of the whole stats circle. And so that's where I'm getting that 0.29. Now, explain to a board member that may or may not understand statistics what this means exactly. So here's what I'm saying. I want the probability that a student is enrolled in AP Calculus given that they are enrolled in statistics. So this would mean that 29% of the students enrolled in statistics are also enrolled in calculus. And again, there's other ways you could say that. You could say if you're enrolled in statistics, there's a 29% chance that you'd be enrolled in calculus, right? A lot of different ways you could say that, but that typically is what most people will say. Okay, again, send questions as you have them. We finally got a couple people on, so feel free to send them either on Remind or on the YouTube chat if you've got them. All right, next one. There are 2,000 students in Hilton High. The counseling office states that there are 355 seniors in the building. Mr. Dornan reports that 280 students with parking passes. The probability that a student selected at random is a senior or has a parking pass is 461 out of 2,000. What is the probability that a student is a senior with a parking pass? So this is the probability that you're a senior and you have a parking pass. So here's what I need to know. I see this or in here. So probability that you're a senior or you have a parking pass should equal the probability that you're a senior plus the probability that you have a parking pass minus the probability that you're a senior and you have a parking pass. So I'm trying to solve for this, right? Probability that you're one or the other is 461 out of 2,000. Probability that you're a senior, well, I know that there are 355 seniors in the building. And probability that you have a parking pass, there's 280 in the building. So 280 out of 2,000. Minus that quantity, which I'm going to call X here, right? So that's really what I'm looking at. So now to get this, I'm going to combine my like terms on the right side. So 355 plus 280, I'm just adding my numerators. This would be 635, and that's going to give me that x equals 174 out of 2,000. So that's the probability that you're a senior and you have a parking pass. Again, I just added these and then I subtracted it over to get x alone. Okay, let's do a couple more quick probability ones. So given S and M such that P of S is 0.33, P of M is 0.61, P of S union M, which is OR, is 0.94, determine if they're independent or dependent. So if they're independent, then probability of S times probability of M should equal the probability of S and M, right? That's your probability formula for independence. So notice we've got this 0.33. We've got this 0.61. We don't have this, so we need to figure that out. So I know that probability of S or M should equal probability of S plus probability of M minus probability of S and M. So that's exactly what we did on the last problem. So this is going to be 0.94 equals 0.33 plus 0.61 minus our x value there. Now, something very interesting is going to happen here because 0.61 plus 0.33 is 0.94. And so what you get here is that that is 0. So what I want to know is, well, does that come out to be 0? It certainly does not. And so I would say that these are not independent. Okay, let's look at the next one. So, a jar contains red marbles and chartreuse marbles in the quantity shown below. So, RRR, 4 reds, CCC, 3 chartreuses. 2 marbles are randomly drawn from the jar, one after the other, without replacement. So, that means I'm not putting it back, right? So, what is the probability that the first marble is chartreuse and the second marble is red? So, I want probability of C and R. Remember, and should make you think multiply. So that would be probability that it's chartreuse, which is 3 out of 7. And then we're not replacing that. So probability that it's red is going to be 4. But now there's only 6 left, right? Because now we've eliminated one of those. So again, I'm doing the probability of drawing a chartreuse, which is 3 out of 7. And then if I'm not replacing that, this would be the probability of a red after that, which would be 4 out of 6. So this probability is 12 out of 42. Now, let's see, are these independent? Justify your answers. So here's what I would need. Probability of A times probability of B, and they're defining those for me here.